Hello, and thank you for attending this webinar on building an open source governance program for enterprise ML and AI. My name is Chang Li, and I am a principal software engineer at Anaconda. I've been a software developer for more than 2 decades, and before joining Anaconda, I spent most of my career as a scientific software developer in both academia and industry, focusing primarily on developing tools for high throughput genomics. I'm also a maintainer on several open source projects, including the Anaconda package manager and its associated tools. The agenda for today's webinar. We'll first start with some background so we all understand what open source is, why you might adopt it for your enterprise machine learning and AI needs, and why you need a governance program around open source tools. After that, we'll discuss some factors to consider when designing and developing an open source governance program. And then I'll talk about some suggested steps for building such a program. And then we'll finally wrap up by summarizing a few key takeaways. So for some background. So what is open source software? Open source software, as the Open Source Initiative, OSI, says, is not just about access to the source code. As mathematicians would say, access to source code is a necessary but not sufficient condition for some project to qualify as open source. Generally, there are 3 accepted points about what makes a piece of software open source. First, it should allow distribution, not just access, but distribution in both source code or precompiled form without needing monetary compensation. Second, and this is the critical feature in my opinion, is that open source software allows users to make and distribute modifications and derived works without seeking permission first. And finally, most people can require that open source software not discriminate against persons, groups, or fields of endeavor. And non-discrimination against fields of endeavor means that you can use open source software for commercial purposes, including products you might sell, so long as you follow the requirements of the license of that software. And one other thing to keep in mind is that open source extends to fields beyond software, and what Lawrence Lessig has called remix culture. The concepts here, redistribution, modification, non-discrimination against fields of endeavor, applies to things like media. And particularly in the context of machine learning and AI, keep in mind that open source principles can also apply to other things needed for your AI workloads, such as models and data. So why are enterprises choosing open source? I would argue that in 2023, it's no longer a question of if your organization is using open source. You already are. Rather, the question is more around how much open source you're using and where you're using it. For example, open source includes many of the major well-known data science, ML, and AI frameworks such as PyTorch and TensorFlow. The software running your production systems, the Linux operating system, Kubernetes, are also open source. And in fact, many popular web browsers, Chrome, Firefox, even Microsoft Edge, are either open source or heavily rely on open source components. So again, it's not a question of if, it's a question of how much and where. So why is open source so popular? There are a number of factors that include low barriers to entry. Pretty much all open source software can be obtained for free. There are many open source projects, so you have more choice. If you don't like a project, you can pick a competitor, and it reduces vendor lock-in. Open source software, particularly in data science, machine learning, AI, is characterized by rapid innovation. For example, most deep learning frameworks are open source. Open source also provides greater transparency. You can see the source code. You can talk to the maintainers. And in general, open source, in 2023, fulfills many of the requirements for security and quality we would expect from software. Taking a look, for example, in terms of open source adoption is Red Hat's State of Open Source Survey in 2022. IT leaders are currently making use of emerging technologies. 71% of the 1,300 or so respondees in Red Hat surveys said they're using some sort of open source for AI and machine learning. They're using it on the edge compute in their containers and their basically day-to-day computing. So again, to emphasize, your data teams are almost certainly already using open source software. It's just a question of whether you know that they are. So what are risks associated with open source? Open source, I would say, is no different than any other software, like proprietary software. They're much of the same considerations and risk. You have to think through your acquisition process. How do you decide what open source software to use? Lifecycle management. How do you get that once you've decided? How do you get that software into your organization, out to your users? How do you update the versions you're running? And if necessary, how do you retire software? There are also questions and considerations around support and training. Are your users able to use the software that they've selected or that you've selected? There are questions around licensing, and particularly if you are developing products, licensing, as I'll mention, discuss a little later on, often comes up as a major concern. And of course, in the era, if you look in any of the major technology press, security, software security, and software supply chain security is one of, if not the major concern these days. So while the considerations, the factors you have to think about are the same, the nature of open source software means you might have to take different approaches to managing it. For example, low barriers to entry that I mentioned, basically that it's free, means that a lot of users adopt it under the guise of what's typically called shadow IT. Essentially, they have downloaded and are using the open source software outside your established IT controls and processes. More choice, greater transparency leads to supply chain complexity. And because there's not usually a single traditional software vendor, means that a lot of the burden shifts to being in-house and do it yourself work. So, for example, instead of buying a single product, you may have to grab multiple open source components and figure out how to integrate them internally. You may need to build your own in-house skill and your own in-house training material. And again, not a single vendor. So the innovation and the security notifications may fall upon your organization to keep informed and updated. And one thing I would like to point out, although there are many similar considerations for proprietary software, one of the key points of open source, as I mentioned earlier, is this concept of remix culture. And so with open source software, one of the things you will have to start thinking about is how you want to be involved in the community that uses and builds the software you've selected. So what is an open source governance program? I particularly love this quote from Scott Hanselman in 2006, which is, open source, to summarize it, is open source is free like a puppy is free. It sounds great, but there are a lot of things you may not consider when you first pick it up. So at its core, an open source governance program is a formal set of policies, processes, and tools that ensure the successful adoption and use of open source components to achieve your enterprise objectives while mitigating some of the risks. So what are the elements of an open source program? What I'm about to talk about is kind of the highlights and the major elements, but it's certainly not necessarily a comprehensive list. Acquisition considerations. Let's start with that. You need to understand why your users have selected an open source component, which open source components they want to adopt, and the decision-making behind that. Why use open source instead of some proprietary vendors' products? You need to develop criteria and assessments and concrete ways of making decisions, right? How do you weigh the business needs against factors like security and the project's maturity level? And I would say that open source makes the software supply chain and dependencies in particular much more transparent. What do I mean by that? A survey by Sonatype, who's a security vendor, done last year and published earlier this year in 2023, identified that on average, each open source, commonly used open source library has about 6 dependencies. So 6 other libraries or applications or programs that it depends on. And to think, if you think it through, the NumPy, for example, if you install that, or let's say scikit-learn depends on SciPy, which depends on NumPy, which depends on Python, which depends on any number of other things. And I would like to point out that these sorts of complex dependency chains, these number of dependencies are not unique to open source software. The proprietary software has these sorts of complex dependencies. It's just not transparent to you as the user. And this dependencies topic is something that I will repeatedly come back because I think it underlines a lot of the critical decision-making that you have to do. Licensing. Open source licensing compliance, following the license of the open source project you've adopted, is frequently identified as a major concern by enterprises when adopting it. One thing I would like to point out is to correct a possibly common misconception that open source is license or copyright free. In fact, the opposite is true. Open source works because of copyright law and because of licenses. They basically rely on their license to make sure they remain open source and they remain viable as something that people can contribute to. One thing to keep in mind is that not all open source licenses are the same. For example, you may have to consider things like copyleft licenses, the GNU Public License, GPL, versus more permissive ones, what are generally called permissive ones like the BSD or MIT licenses. These licenses carry various obligations and risks, particularly around the IP that your organization builds around these tools. For example, if you are a commercial software vendor, if you build commercial tooling, GPL licenses, these copyleft licenses, are something you might choose to avoid because they obligate you to release whatever tools you build with on top of the GPL component under the GPL license as well. Whereas a permissive license such as BSD basically allows you to take and reuse those components without further releasing your product as open source. And keep in mind, as I mentioned earlier, remix culture has entered the technology zeitgeist, and that data and models will have their own licenses, some of which are open source, some of which may impose copyleft-like restrictions, some of which are permissive open source, and some of which are completely proprietary and restrict how you can use such data and models. Lifecycle management is another major consideration. Once your organization has decided to adopt open source, there are a number of things to consider. For example, starting from the basics, do you want to build these open source from source, or do you want to obtain them in some form of pre-packaged form, pre-built, pre-packaged form? Anaconda, for example, simplifies some of the lifecycle management of open source components by offering a paid repository where we as a company have handled the complexities of building open source tools from scratch, and your users can basically just use a prepackaged binary. Going further from that, you have to think about how users obtain and update the software, the open source software they're using. Typically, because of the nature of these open source projects, they might not integrate well with some of the more traditional IT deployment tools that are out there. This is changing, but it's something to keep in mind. You also have to think about how you, as an organization, you maintain visibility into the usage of open source software. This may be for a number of reasons. For example, you would like to know how many users are using it. How do you notify them for that they might need to apply a security update? If you're a software development company, you might need to maintain visibility to make sure that, for example, GPL code does not sneak into your proprietary software. And finally, another component of lifecycle that I think is undervalued or underappreciated is end of life. Software has an expiration date in the sense that at some point, most maintainers will decide they are no longer supporting a version of some software, and you have to figure out, how do you handle that? Do you upgrade? Do you find an alternative tool? And how do you get all the things that depend on the end of life software to the state you need it to be to continue supporting it internally? Security. Security, I would say, by and large, is the most frequently identified top concern of using open source software. And this is backed up by a survey that was done recently by the Open Source Initiative and OpenLogic, where 40% of respondents said their top concern about using open source software is maintaining compliance with their security policies and keeping up to date. The good news is, by and large, open source security is in a relatively good state. Again, going back to Red Hat's State of Enterprise Open Source survey, 89% of respondents believe that enterprise open source is as secure or more secure than proprietary software. And I think this has been backed up by decades of experience as an industry. And to dig further into this, one of the things that has commonly been said has been that more eyes make all bugs shallow. Namely, the fact that because people can look at the source code, we'll find and resolve security issues more quickly, which is to a certain extent true, as you can see in the two points there. But more critically, it allows a community to build around it. For example, there are a number of security vendors, including Anaconda, including Sonatype, where because tools are open source, we can look at the source and verify that a fix has actually been applied and that it has been documented, and we can build scanning tools around it. The number and popularity also makes open source tools very well tested. So security bugs tend to be discovered fairly quickly, and importantly, they tend to also be corrected very quickly in a public way. That said, theory and practice within your organization may be quite different when it comes to open source security. Again, going back to the in-house DIY nature of open source, vulnerability and remediation data may be hard to attain. It may be something that you will have to look at a third-party vendor to provide for you. One thing to also keep in mind is that risk assessment is frequently contextual and requires some level of security expertise. I would caution organizations to be careful about just looking at the CVSS scores, the CVE scores, and making risk assessments based on that. Because it's frequently contextual in the sense that if you look at a component such as Python, for example, the Python standard library is huge. Similarly, other common data science tools like scikit-learn, the API, the library is huge. And whether a specific and reported vulnerability impacts your organization will depend, for example, on whether you use that part of the tooling, right? Whether you use, for example, there was a recent announcement of a vulnerability discovered in the Python standard library's mailcap module. And I would argue that from the majority of organizations, that vulnerability was basically zero risk, because no organization that I'm aware of actually uses the Python mailcap. If you don't use the code, then you're not vulnerable. Getting fixes out to the right places also requires, again, visibility and effort. Open source tools may not integrate with your in-house enterprise SIEM and other security management tools. And again, we come back to dependencies. Keep in mind that the vulnerability that's going to be a greatest risk to your organization may be somewhere in the chain of dependencies and not necessarily in the component that you interact with day to day. Security, as I said, is a chain of rather imperfect links, and your goal is to minimize risk to each of those links. Support, again, coming back to DIY. Support is also, in that OSI survey, was also identified as a major concern. And this basically means you have to build your own in-house expertise, because there might not be a vendor in the traditional sense to provide training that you would need. Open source projects are largely to exclusively volunteer-driven, and they vary in the number of contributors. Some may have hundreds of thousands of contributors, and some, and including some fairly popular frameworks, have maybe one or two. And so support expectations will differ from project to project. If the If the project has enough contributors, enough maintainers, you might be able to get a very quick response on GitHub on basic things. Otherwise, issues may sit there for months or years. Documentation in open source can occasionally be sparse or outdated. And also keep in mind, as I mentioned, in build from source versus prepackaged, that the development team, the maintainers of that open source library, and the supplier from whom you got the software you're actually deploying may not be the same organizations. And again, that will change the level of security expectations. And then community participation. Again, this is kind of the key difference between open source and proprietary software. Open source allows enterprise to be in better control of their own destiny. Because the source is available, because work is done in public. You have a choice to go from just a mere consumer of a software tool, a software product, to participating, to contributing, and then to being a leader in that product. And the Linux Foundation's Guide to Enterprise Security has a great explanation for this ladder from a consumer to a leader. Sustainability is a concern for many open source projects. As I mentioned earlier, some projects may have one or two maintainers, and they turn out to be fairly critical in terms of the global software ecosystem. Open source projects thrive when their users actively participate and actively contribute. And keep in mind that contributions need not be code. So if your organization decides to participate, to contribute to a project, you don't necessarily have to contribute code, which is useful, for example, if your data team, your data science team, your machine learning teams are part of an enterprise that aren't necessarily software developers by trade. Like your business is not building and selling software. Contributions can take the form, in very basic terms, as providing donations to organizations such as NumFocus or the Linux Foundation, which in turn use that to fund and pay developers for open source projects. It can be participating and helping other users adopt and learn how to use the software. It can be helping update documentation. So again, contributions need not be code. The other thing to keep in mind, because this is a largely volunteer-based system, it's generally considered rude to demand, or almost certainly considered rude to demand. Don't demand, collaborate. Find a way to engage with the maintainers, with the broader community, to build the better world that you want, the better tooling that you want. So given all those factors, how do you go about building building an open source governance program? The first step, I would argue, is to obtain leadership buy-in. Once you decide or feel that your organization needs a governance program, you need to find a champion. And often this is in the form of someone in the C-suite, in the executive suite, either the CISO, the Chief Information Security Officer, or your Chief Data Officer, or some other executive. And this is because their level of authority and credibility tend to make sure that whatever program you develop gets adopted and is sustainable. Once you have found a champion, you need to form a program committee. And to form this, you need to identify representatives from the various stakeholder groups within your organizations, including obviously the users, your data scientists, your data analysts, IT, and security, so the people who are actually managing software within your organization. And again, I think this often gets looked over. You should probably involve your legal and compliance departments because, as I mentioned before, licensing is a concern. And to deal with licensing, you need to talk to your lawyers. And the purpose of this program committee is to actually develop, implement, enforce, and maintain the governance program. Once the committee is formed, what do they need to do? They need to first start by deciding on the policies. How are you going to adopt, distribute, use, and retire open source software within your organizations? And among other things in these policies, you need to consider the upstream project factors. What are the license of the software that you're going to adopt. And keep in mind, again, dependencies. With copyleft license, you may end up finding yourself with GPL software because something on your dependency chain turns out to be GPL, even if the software that you originally started to adopt is licensed under some other term. Sustainability has to do with how active the application is maintained. Do you have confidence that you will be able to get updates or get bug fixes? And along those lines, the community, are there people you can reach out to get support? Other policies, again, acceptable security risks. Keep in mind that no software is perfect. It will almost, you're pretty much, I would, for lack of a better way of saying it, guaranteed to run into a security issue at some point. But you have to have some policy to guide you in your risk-taking decision. In this way, for example, a naive policy, for example, maybe we'll just update all the software. But software fixes, security fixes don't stand alone, generally speaking. And if you decide just to update to the latest version of every piece of code, you may find that what you've built upon breaks because this new release not only contained a security fix, but changes other fixes, other code changes that lead to changes in behavior or changes in API. Another policy is to keep in mind when developing policies is how will you get user buy-in? This means you need to think about policies that don't become a burden to your user. For example, you probably want to avoid a policy such as you need written approval from multiple people before you can upgrade a version, because that's going to generate friction and that's going to lower compliance. And essentially you will find yourself, instead of having open source under a reasonable governance program, users reverting back to shadow IT and using open source in a way that is not visible across the organization. And finally, contributions. Think about how, if and how you will contribute back to the community. Once you have your policies, you need to convert them into processes. And these include, again, all the things I've mentioned. How do you get the software into your organization? How do you deploy it? Is it automated tooling? Is it telling users to manually upgrade? The lifecycle management. How do you record when a piece of software comes in, when it has been updated, and when it has been retired? Monitoring and notification. You need to keep track of who is using open source within your organization. And you need to make sure that your users are supported and that they have the training to properly use the software. And whether that means building, again, these programs in-house, finding another vendor to provide all of these, or working with the community to cooperatively build these sorts of support and training materials. And once you have your policies and processes, it's time to start thinking about tooling and especially automation. Practically speaking, open source software management, actually most software management cannot be done by hand. If you have a large enough organizations, you cannot reasonably expect to ask users to manually input what versions of software they are using. They might not even know. So you will have to think about, for example, how do you build tooling for centralized software distribution? Again, is this something you build in-house, or do you find a third-party vendor to provide a software distribution and the necessary management tools? Lifecycle management. How do you push auto updates? Again, open source tools by their nature are very unlikely to be integrated into things like Windows Update or the Mac OS Updater. So you'll have to start thinking about the tooling you need to push updates out to the users. And then monitoring and notification. Again, you cannot reasonably expect your users to continually manually fill out paperwork. So you need a way to collect information from their systems about the software they're using, and more critically, to notify them, for example, if there's a security fix and they need to update. And once you have done all that, it's time to move towards the adoption phase. The adoption phase starts with communicating to your user base that this is the governance policy. You need to train them on the policy. You need to make sure that as I mentioned, you have buy-in from your users and they understand what needs to be done and why. And then again, there's, as I mentioned, monitoring is important, but you not only need to monitor the software, you need to monitor the health of your program itself. And critically, you will almost surely not get it right the first time. And you will need to continue to monitor the efficacy of the program and revise it as time goes on. So to summarize, what are the key takeaways? First, open source adoption is a reality for your enterprise. Your users are already using open source, and you need to figure out a way to maintain at least some level of control over it. Secondly, open source has many of the same considerations as traditional proprietary software, but it requires you to adjust approaches, how you approach those concerns, mostly because you don't have a single vendor you can rely on. And finally, a governance program is critical for ensuring successful adoption and usage and minimizing the risk of the open source software being used in your organization. Thank you very much for attending this webinar.